In this demonstration, we're going to take a look at the SortedList class. The sorted list is kind of like a cross between a standard generic list and a dictionary. If you look at the definition of a sorted list, when you create it, you must provide both a key and a value for each item that is provided to the list. We could create a list of strings that have keys of type int. And I'll call this sorted, set it equal to a new list. Then when I add items, I can add them by key and the string value I wish to use. I may also use the indexer syntax as such. When you add items to the list, each new item is sorted based on the key provided for that element. Since we are providing an int for the key, it will use the standard integer sorting algorithms to place these items in the list. So right now, 1, 2, 3 comes before 2, 3, 4. So if we print each item that's in the list, we can see that the items are in fact printed in A, B, C, D, E, F order. If I were to change the keys so that this was 34 instead of 234, now DEF will come first because it has a lower integer value. We are also able to use custom objects in our sorted lists. So we could define a sorted list of person objects, which is defined as having last name, first name, and date of birth, has a toString method, but most importantly, it's iComparable, and therefore it has the compare_to method. So when we add these items to the list, because I'm also using the person object as the key, it will utilize the compare_to method defined here to sort the items into the sorted list. Let's create a person P1, set it equal to new person, Smith, John, and datetime.parse 1/2/1993. Then we'll create a person P2. This will be Jones, Frank, 3/1/1985. And let's do one more person. Make this person Sally Jackson, born 4/12/1995. Then we can add these people to the list. And notice I'm repeating P1 for both the key and the value, then P2 for both a key and a value, and then finally P3 for both a key and a value. Then I can use a very similar technique for printing all of them by using a loop. It's not a string this time, but I can call it var. And notice here when I iterate through the list, I'm not just saying for each of the items in people, because that's going to give me a key value pair. What I really need to do is loop through its values, which will be in a sorted order. Now let's take a look at what that sorted order is going to be in this case. Person has the compare_to method implemented such that the first thing it compares are the last names of two people. If they're equal, then it compares the first names. And if they're equal, it finally tries to determine which one should come first based on their dates of birth. So we know that Jackson should come first, then Jones, then Smith. So we should actually see these items printed in the reverse order that they were added to the list. And they are Jackson, Jones, and Smith. This is actually a fairly efficient algorithm in place because it doesn't sort an entire list all at once. It sorts the items as they're being added. So in total, it may take more time to sort individual items one at a time than it would be to do one master sort at the end. However, you are always guaranteed the items are in sorted order, so if you add yet another item after doing a complete sort, you would have to pay the penalty of that complete sort again with the typical list. With this one, however, you're paying a small fraction of time every time you add a new element. You can also specify if you don't want to use the default compare to method of the key element, you can define a separate class that implements the iComparer interface. I'll go back to person, and I'm going to create a new interface class. And I'm going to create a new class. I'll call it person comparer. Let's call it person date of birth comparer, DOB comparer. And this is going to implement iComparer of type person. Now I implement the interface, which gives me this compare method that has two person objects. And just like compare to, I need to return -1 if person X is less than person Y, 0 if X and Y are equal, and 1 if person X is greater than Y. First, we need to check to see if both X and Y are null. So if X equals null and Y equals null, return 0. If they're both null, they are equal. Else, if X is null, we don't need to check for Y again, then we know that X is going to be less than Y because we're assuming that null values are less than concrete or real values. Else, if Y is null, we return 1. This takes care of all of the null options. If we get past all of these checks, then we can begin the actual item comparisons, which we will do in a very similar manner to what we did in the compare to method of the person class itself. We create a compare variable that will contain the result of comparing two items together, and we're going to use X and Y as the prefixes to the objects. We'll change all the others to Y's, just to start with. Then the ones that don't have a prefix, we'll add X dot to. So we'll do that with last name, first name, and date of birth, which will give us an adequate comparison algorithm if we intend to sort first by last name, then first name, then date of birth. But by the name of the class, it says person DOB comparer. This is probably not what we actually want to do. So I'm going to take this first compare here and replace it, the last name compare, with the date of birth compare first. Then I will repeat the if statements that we had prior. So we compare the date of births together. If they're equal, then we have to compare the last names. If they're equal, then we compare the first names. We don't need to do this inside check anymore because once we've done date of birth, last name, and first name, we have compared all of the elements. Now we can utilize our new comparer in a sorted list of type person. One thing that we can do is take a look at the constructor here, and one of the constructors accepts an iComparer of type person. If we pass our new person date of birth comparer as a parameter, now when this list is sorted, it is going to look at the dates of birth first, where we have 1985 is first, then 93, then 95. So hopefully we'll end up with Jones, followed by Smith, followed by Jackson. Jones, Smith, and Jackson, based on the dates of birth. So if you need to maintain a list of items in a sorted order, the sorted list may be a better choice than either the generic list or dictionary classes.